All right, back where this is 9.1 part 3. And we're given some formulas that will help us calculate sigma or calculate sums. When I say calculate sums, there's always two ways to calculate a sum. One is you can just add the terms together, just add them up by hand. But the idea of using these formulas is to gain some practice in using these formulas, but it's also to help us with very large sums. For example, I wouldn't trust myself to add, 20 numbers together. That's usually my limit. If they're fractions, probably 8 or 9 fractions. But if they weren't fractions, I'd say, if I had to add 20 numbers together, I'd be a little worried without, using a spreadsheet or something. So there are ways to add thousands of numbers together potentially with just a formula, and that's what we want if the numbers are in a sequence and we know the pattern to that sequence. All right, so I already talked about this one in the other video, that we can factor out the c, whatever that constant term is, and it gives us just the formula involving the variable. Since you can add in any order, these kind of make sense, these next two. If I have the sum of two formulas, I can add them up separately, and that's sometimes important. This one as well, subtracting. And you'll see how that, I'll call it kind of a distributive property idea works. This one is where a lot of students really fall off because it's number line thinking. And again, I've mentioned number line thinking seems to be hard because students just don't do it. So as we're going to see in the very next slide, we have ways of finding the first n term. So when I say first n terms, that means k starts at 1 and goes to n, the first n terms of a sequence. What if you didn't want to find the first n terms? What if you wanted to find from 5 to 10? But you didn't have a formula for finding 5 to 10. You only had formulas that found 1 to a certain number. Well, the idea here is you want to use your formulas to find 1 through 10. Now hear what you're saying. If I want 5 through 10, why would I want 1 through 10? Well, that's just a start. 1 through 10 would give you the first 10, and then you'd want to subtract terms 1 through 4. So just as an oversimplification, if I said 1 plus 2 plus 3 plus 4, 5, 6, and let's say you had a button on your calculator. Okay, it's not quite that simple, but let's say you had a button on your calculator that did nothing but add things together like 1 through a number. It doesn't add 5 through 10, it adds 1 through 10. All right, and you want to find this. Well, what this formula is saying is, go ahead and find 1 through 10, but subtract 1 through 4. All right. It wouldn't be wouldn't be counting numbers, they'd be terms of a sequence. But as we're going to see, we have formulas that allow us to find sequences as long as they start at 1. All right, so here they are. So of course, these formulas, have them ready to use, written down somewhere. I'll give a couple of examples here. If I just said, the sum k equals 1 through 10 of the number 6, that would just mean 6 plus 6 plus 6, 10 times. It would just be 10 times 6. So that one wasn't much of a formula really. But how about this one here? Let's put a 10 in all of these. If I wanted to find the sum of the numbers 1 through 10, of course I could do that without this formula, but this formula, it tells us it's 10 times 11 over 2. I'm just putting a 10 in for n because all the systems are right. I'm starting at 1, I'm finishing at 10, so I put 10 in there. That's going to be 55. So I just added the numbers 1 through 10. Not quite in my head, but it's a lot easier than actually listing the numbers, adding the numbers, and certainly using a calculator. All right, let's put a 10 here. What are the first 10 perfect squares? Well, I mean, we could list them, 1, 2, 3, 1 squared, 3 squared, so it'd be 1, 4, 9, then 16, 25. It would stop at 100. And I want to add all these up. And this is what I'm talking about. I'd be willing to add 10 numbers up with or without a calculator, but I wouldn't want to add 20 or more. I'd just be worried about making a calculation error. A little worried about it here, but let's see. It's 10 times 11 times 21 all over 6. And I got that just from this formula. Let's see, this 6 has a 3 in it, so I can factor, and I'll get 7 and a 5. And so I have, yep, I'm going to use a calculator. 5 times 11 times 7. $385. So it appears that the sum of the first 10 perfect squares is, well, 385. Not something I would try to do if I didn't have that formula, but it's nice to have. All right. How about the sum of the first perfect cubes? Well, this might look familiar because it's just this term squared. So that's kind of an interesting revelation that if 1 through 10, the numbers 1 through 10 add up to 55, the perfect cubes, 1 cubed, 2 cubed, 3 cubed, up to 10 cubed would be 55 squared. And I could just use that formula and put it in there. But notice it's giving us values from 1 to whatever number we put in. Kind of amazing. All right, so a couple of other rules here. This was the number line thinking idea that I was talking about. I know I can find, well, I know I can factor out the 3. So I have 3 sigma k squared. But notice this is going from 6 to 20, which is not really helpful to me. And understand, I cannot just change that to 1 to 14 or something like that, because changing the numbers here would also change the numbers in the formula. So I set it up as to what we'd need to do on this problem. What we need to do is factor out the 3 and calculate 1 to 20 using the formula on the previous page, but subtract 1 through 5. Now, why 1 through 5? Because if I subtract 1 through 5, it means I'm leaving 6 through 20 in that calculation. So I bring that up because of the number line thinking that students have trouble with. This is as close to an example that you're going to see in the homework as I think we ever have in the book, where we have an example in the book and that's so closely matched to the homework. This one right here. So let me go through that one, the reasoning you might use. All right, so for part C, we have the sum of this trinomial, and your job is to break it into separate sums and then just use those formulas on the formula page to calculate these. Again, the alternative is you could plug in the 1, calculate that to 2 up to 24 and add them all up, but you'd be adding up a lot of numbers. So this, as unusual as this looks as an adding strategy, it really is the best idea. So you can see how the first term became from 1 to 24, so we're putting 24s in all the formula, all the places, which eventually calculated to 4,900. 5 times k, and remember the formula for k, the formula we're using here is n plus 1 over 2. Well, if n is 24, substitute those values. And then, of course, just adding 3 24 times would be 3 times 24. So you run all those calculations and you get this number. And I just want you to appreciate, we just added 24 fairly complicated formulas or expressions and did it without very much addition. So that's the power of knowing these formulas. Now remember, that was C. D, remember, was the one that didn't start at 1. So we have to change the calculations to 2 calculations that do start at 1, and it gives us these numbers here. All right, well, that is all that we're going to cover in 9.1. So in 9.1, there was a lot here, 3 videos worth, but just to summarize the idea, or to encapsulate the idea, you're going to see some notation that you didn't see before in other classes. With the sigma, you're going to treat lists of numbers not like lists of numbers, but like an algebra student would treat a list of numbers. So when you see a list of numbers, your job isn't just to look at that list, it's to manipulate it somehow, to put it into a formula, or in this case, to add them all up. But all right, that is 9.1. I will say we're going to do 2 other sections in Chapter 9, and they feel very different than this. So each section of Chapter 9 could belong to a totally different chapter. They don't really have as much of an integrating quality as most other sections do. So just remember where you are when you're in section 9.1. You're doing these types of problems. When you're in, section 9.5, the problems are totally different. But all right, that's 9.1, and I'll see you in the next video.